So we've got a question here on complex analysis. This function z, 2z cubed plus 5z minus 1. We're looking to find the location, so not evaluate them exactly, but find the location of the zeros using Rouchès theorem. And looking in this diagram here, this is where we're going to find the zeros. We've got two lines. Region 1 is modulus of z is 1. So that's just the unit circle with radius 1 centered at the origin, which is this one. Region 2, or line 2, is modulus of z is 2. So that's the circle of radius 2 centered at the origin as well. And again, the radius of that line is going to be 2. And outside is just the complex plane. So I've just labelled that as the complex plane. So how are we going to do that? Finding those with Rouchès theorem. So we've got this function here. Now we can see that this function is analytic everywhere on the complex plane. So that's a great start. As it's a polynomial, that's always going to be the case. And we can see that's a polynomial of degree 3. So by the fundamental theorem of arithmetic, this has 3 zeros altogether. So we write that here. F has 3 zeros. I just say that they're in the complex plane. So in the complex plane. Okay, so that's the inside, so that's within the set of the complex plane. So how are we going to find out if they're here in this perimeter here or inside this radius of circle 1? We will use something called the Triangle Inequality, and then we assign a dominant term for each one of these. So let's start with region 1. So region 1, that's where modulus of z equals 1. So when modulus of z equals 1, which is the dominant term? Well, that would be 2. 1 cubed is 1 times 2 is 2. That would be 5. So this is the dominant term in region 1. So we let g1 of z, let's make that look like a z, not a 2, equal 5z. Okay, and then now we set up the triangle inequality. So we say f of z minus g1 of z equals, so we take this term out of here, and that will leave us with 2z cubed minus 1. So we stick again with the modulus sign. You can't just say equals and not have the modulus sign, it won't make any sense. 2z cubed minus 1. Okay, so now we can just go through the triangle inequality stages, and now we say that this term is less than or equal to 2z cubed plus minus 1. Okay, now we just keep going down and keep going along and breaking this down. So we say that this is less than or equal to 2z cubed, let's make that look like a proper 2, and then plus a modulus of minus 1, well that's just going to be plus 1. Okay, so now for this region 1 where modulus of z equals 1, we just now plug in 1 for this value here. So 2 times 1 cubed is 2, plus 1 is 3. Okay, now we need this value here for g1 of z for region 1. So when they say now that 5z when z is 1, we just say that that is 5. So now we can see that 3 is less than 5. Okay, so by the triangle inequality, what we can say is that there are the same amount of zeros within this circle here as the polynomial of g1. So what we can say is, by Rouchès theorem, there are 1 0. So as this is the dominant term, we say there is. So there's not multiple, so we say there is 1 0 inside. So it's not going to be on the border, because at 1 they're not equal. So there is 1, 0, let's make that look like a proper 1, inside R1. Okay, so we know there's 1, 0 in there. We don't know where it is yet, but it's definitely in there somewhere. So we just put a little asterisk for that. Now what we want to do is find out if there's any zeros in this bit here. So now we concern ourselves with the second region. So that one there, the modulus of z, let's just put semicolons there, equals 2. So now we're looking for the dominant term again. So when modulus of z is 2, this one is going to be the dominant term, because that's 5 2s are 10, or 2 cubed is 8 times 2 is 16, so that's the dominant term. So now we'll let G2 of z equal 2z cubed. Now just plugging in for when z is 2, we'll let that equal 2 cubed is 8 times 2 is 16. So we evaluated that on this point here. So now let's start off the triangle inequality. So f of z minus g2 of z, modulus of that. So we're still on the modulus, so we open it up, that equals the function minus g2 of z. So that's 5z minus 1. Okay, right, now we go through the stages of the triangle inequality, just like we did here. So we say that this term is less than or equal to modulus 5z plus the modulus of minus 1. Okay, now let's continue here with the triangle inequality. So that's less than or equal to 5 times the modulus of z plus the modulus of minus 1 is plus 1. So now if we just come over here, plug in the values for 2, 5 2s are 10 plus 1, that's 11. So that equals 11. So if I just write that there. Now we see that 11 is less than or equal to, well, it's less than 16. Okay. So now what we can say is that there is the same number of zeros within this circle 2, that's in the whole circle, because we're not calculating for here with these calculations, we've eliminated this one separately. So we can say just 3 zeros inside the radius of 2, circle of radius 2. And there's 3 zeros by this term here. So as that's a cubed, there is 3 zeros to be found inside there. So we can say now this line here by Rouchès Theorem there are 3 zeros inside region 2. Okay. Right, so we've got 3 zeros inside here, but we know there's 1 in here. So therefore, by the process of elimination, and we know there's not any on the actual line, there must be 2 in here somewhere. Again, we don't know where they are. Let's just put 1 there and 1 there, because I'll explain why that will probably be the case. Okay, so therefore there's 2 zeros inside here and 1 0 inside here. Now, what we do see here, now where there's 2 inside this bit, these 2 will be a conjugate of each other. So for example, we could be in between minus 1 and minus 2. So for example, we could have this one here at point z equals minus 1.5 plus 0.1 I. That could be a legitimate point for this one here. Now this one will be the conjugate of that, so therefore, so we just call that z1. z2 could equal minus 1.5, so the real number won't change, but as in with conjugate, the imaginary number changes. So that'd be minus 0.1 I. That is a possibility. I'm not saying that these is the exact answer, but that's a possibility. So now we need to think what this number is. So where do we think that would be? Well, we can see here that this 2z cubed plus 5z minus 1, if z is 0, we will get 0 plus 0 minus 1. So therefore, that would not make any sense, because if that is set to equal 0 to find the solutions, we'd have minus 1 equals 0, which doesn't make any sense. So we know it's not 0, so it's definitely not on that point there. Now, are they going to be on this side or on this side? So we just got minus 1 for 0. So as this one and this one will both be positive for the values of z, we can say that the solutions for the third point here are going to be on the positive axis. So they will be somewhere here. Okay, now we can say it's going to be on the axis because it will be conjugate of itself. So for example, let's write down here example 2. Z3 equals, now let's say for example, let's say we got this point here, 0.5 plus, again we'll try 0.1 again, 0.1i. If that is Z3, the conjugate of that would be 0.5 minus 0.1i. Well, this is not the case. So the only way this can be conjugate of itself is if the imaginary number is 0. So therefore it has to be on this real axis. So now what we do is we say that, and we can take that one out. So now what we can say is that these imaginary numbers can all disappear, and then we have 0.5 equals 0.5, and that would work. I'm not saying 0.5 is the answer, but if you go on Wolfram Alpha, I'm sure he'll give you the real correct answers. But there we go. So the one solution is on the real axis, positive, and the other two solutions are inside this second circle here, and they are conjugate to each other. Okay.